We solve this question also. Let f of x is equal to 5 over 3 minus 2x. Show that this function is 1 to 1. We did this, right? But since it is there, we start from there. So for you to prove that a function is 1 to 1, this function, you can't see the board.
No, sir.
What of now? Okay, so let's start from there. We are saying that we talked about this question. Let f of x is equal to 5 over 3 minus 2x. Show that this function is 1 to 1. We talked about this, so I don't know if it's necessary for us to start from there. Is it okay? We can start from question 2, or we solve again. For a function to Okay, for you to prove that a function is 1 to 1, what you have to do is f of a has to be equal to f of b. What it means there is that in this function which you have, where there is x, we are going to put a. Where there is x again, when you say f of b, where there is x, we are going to put b. Now, if you discover to say the final answer is a is equal to b, then this function is 1 to 1. But if a is not equal to b, then the function is not 1 to 1. Does that make sense? Yes, it does. So what I'm going to do now is I'm going to say that I have 5 f. We're saying that f of a has to be equal to f of b. So what we're going to do there is, where there is 5, we are going to say where there is x, we are going to put in a. So it's going to be like this. Then here where there is that one, we are going to put in 3 minus 2a or 2b. Then I'm going to solve this equation. So I'm going to put the a to the left hand side, the b to the right hand side. Okay? So I'm going to cross multiply. So if I cross multiply here, I'm going to get a 5 open brackets 3 minus this is a 2, 2a. So it's going to be 2a has to be equal to a 5 3 minus 2a 2b, sorry. So at this point, if I want, I can distribute. So it's going to be 15 minus a 10a is equal to 15 minus 10b. So I know that this guy, if it comes this side, is going to be 15 minus 15 minus 10 has to be equal to negative 10b. So these, they'll cancel, they'll give us 0. So we're going to have negative 10a is equal to negative 10b. I can divide both sides by negative 10, both sides by negative 10. I can see that what I'm going to have is, I'm going to have a is equal to b. So hence proved. So in short, the first statement, you say that if for a function to be considered to say it is 1 to 1, f of a has to be equal to f of b. That is the first point. Then you start now solving all these stuffs. So you're going to say that since f of a is equal to f of b, then this function is 1 to 1. Ile panga sense. Kathy, is it making sense?
I've gotten, sir.
Thank you. Then we have the next question, which is saying let f of x they are saying let f of x is equal to let f of x let f of x we have a 5 we have a 2 we have a 2 and then we have x minus 1. Then they are saying that determine f of x the inverse of f of x and its domain. So they want us to find the inverse of this function. After finding the inverse, we need to determine its domain. So to find the inverse of the function, you need to replace this with y, then solve for x. So y is going to be 2 over x minus 1. We make x as a subject of formula, we cross multiply. We are going to get y open brackets x minus 1 has to be equal to 2. This is going to give us xy minus y is going to be equal to 2. So we can shift the y to the other side. We are going to have xy is going to be equal to 2 plus y. So we divide both sides by y, we divide both sides by y. So x is going to be equal to 2 plus y over y. Now for you to...
Sir, why have you bypassed the 2? And we solving part 2. 5 over 2 minus 2x.
Oh!
Just want to find the equal.
I'm totally... I was thinking we are solving this one. Totally confused. So they are saying we have 5. We have 5 over 3 minus 2x. We need to determine the what? The inverse of this function. After finding the inverse, then we need to find its domain. So like I said, we need to say y is going to be equal to 5, 3 minus 2x. From here we cross multiply. We are going to get y 3 minus 2x is equal to 5. This is going to give us 3y minus 2xy is equal to 5. We shift this to the other side. We are going to have negative 2xy is going to be equal to 5 minus 3y. We divide both sides by negative 2y, both sides by negative 2y. So x is going to be equal to 5 3y over 2y. Before I continue, I know you sometimes there's some people who are going to say no, you are too fast. So you can tell me if I'm too fast. I'm too fast. Sorry, I'm too fast.
Yes.
I didn't know that I'm too fast. Me, I was thinking I'm too slow. So since I'm too fast, we want everybody to understand. We have a function f of x 5 divided by 3 minus 2x. To find the inverse of the function, what you have to do is you have to set this equal to y. So you replace that one with equal to y. After replacing it with y, then you need to make x as a subject of formula. You need to make x as a subject of formula. Does that make sense, guys? Jaranishita, so you have just to understand me. We need to make x as a subject of formula. What are we going to do? We are going to say that we cross multiply, so it's going to be y. It's the same if you can just say y times this, everything. But for not to make mistakes, you need to do this. It has to be equal to 5. Now I distribute y, so it's going to be 3y minus 2xy is equal to 5. Are we together up to this point? What I'm going to do now, I'm going to shift, since I want to make x as a subject of formula, I need to shift this to the right hand side so that I remain with only negative 2xy. So I'm going to say that I'm going to have negative 2xy is equal to 5 minus 3y. I divide both sides by 2y. I divide both sides by 2y. These they will cancel. This and this, also this and this, will remain with x is equal to 5 minus 3y over negative 2y. Up to this point, any question? Up to this point, any question?
No question, sir.
We continue. We continue.
Yes, let's continue. Yes.
Now from here, after finding the value of x, in a case where you have been asked to find the range, you start from here, you set this one. For example, if they say find the range, you say this, the inverse has not to be, the denominator has not to be equal to 0. That will be the range. You get my point, eh? So what we do now is f of x inverse is going to be equal to this function. This function where there is y, replace it with x. So we are going to say that 5 minus 3x over negative what? Negative 2y. Oh, negative 2x. But this is the same as f of x, this. It is the same even if I can write it like this. I say 5 minus, I divide negative, not so, which is going to give me negative 5 plus 3x over 2x. Again, you can leave it here or you can leave it there, or you can say this is the same as f of x inverse is equal to 3x minus 5 over 2x. So this is the answer, this is the answer, this is the answer. So you can either leave it there or here or here. Does that make sense? We go to the next question, which is saying let f of x is equal to 2. Let f of x is equal to ah, oh, sorry, forgot about that. Now we have found, now let's consider this. We have found that the answer is, we have found that the answer is f of x is equal to 3x minus 5 over 2x. This is the answer. So we want to find the domain. To find the domain, this is the inverse. To find the domain, you have to get the denominator and set it equal not to 0. So we have to say 2x has to be not equal to 0. You get my point, eh? You have a question?
Yes, sir. We're finding the domain of the index, not the test function.
Yes, they are saying that let the f of x is equal to 5 plus c. They are saying, the question is starting from here. Determine f of x and its domain. So they want the domain for the f of for the inverse of this function, not so?
Yes.
Yes. So we're not supposed to find the domain for this one, but they want us to determine first the inverse, and then when we determine the inverse, we need to find the domain of, that's why they're saying its, determine the inverse and its domain. So they want the inverse, then we need to find the domain of the inverse. Okay? Does that make sense?
Yes.
So we divide both sides by 2. We divide both sides by 2. X is not going to be equal to 0. So domain is going to be x is such that x has not to be equal to 0, but x has to be the member of all real numbers. Last time someone asked me to say, why can't we say that, why can't we use, was it integers? The question was, why are we using real numbers? That was the question, not so? Are you, I was teaching you people. Hmm? At what? I was teaching you, right? So now from here, what we have to do is, this is the domain and this is the inverse. Unless you have problems on how to represent this domain in set builder notation. Yes, please.
The question.
Yes, please.
When you're finding the domain and the range, you have to use the equations which are down.
Ask again. What's your question?
Range and domain. You have to use the equations which are down.
The issue is if you have the fraction. Okay. What's your name, madam? What's your name? The one who is asking. See who is actually.
So it's Womba.
Oh, it's Womba. I thought it's Wizard. Okay. What it means? Okay. Do you know what it means when we say domain and range? Whenever we're talking about the domain, we're talking about the values of x. When we talk about the range, we're talking about the values of y. So, for example, let me give you a simple function to say we have f of x is equal to 2x plus 2. If I ask you here to say what is the domain, what would be your answer? Okay, let me give you a simple function. If I give you x squared, now what I want us to do here is I want us to plot this x squared. How is it going to be the function? Hmm? Isn't it going to be like this? It has to touch here, then it goes there, not so? Hmm? Yes, meaning that what it means there is that the values of x are not restricted. This graph will keep on going. We don't know where it's going to end. So it will just keep on going. That's why we say that in this type of equation where this is the linear, where we don't have the radical, we don't have the fraction. So if you don't have a fraction, you don't have anything, it is just like this. Then the domain is all real numbers. Any number you can put it there, the function is going to be defined. But when it comes for range, the range is the values of y. So from the equation which we have here, you can see that the values of y, they are starting from 0 here, going to positive infinity. So the range is going to be, it's going to start from 0, 0 is included, all the way to positive infinity, positive infinity. That would be the range. So you say that the range is going to be y is such that y has to be greater than or equal to 0. You see, because it's starting from here, greater than or equal to 0, then comma, y has to be the member of all real numbers when it comes for this equation. For example, you write a test, you know to say this test I can't go beyond 20%. For example, chemist 1010. You are writing chemist 1010. You write, you are even convinced yourself to say I can't go beyond 30%. What it means there is that those are the values of y, meaning that they can't go beyond 30, meaning that you are starting from 0. There is no negative marking, right? So what it means there is that the graph, your graph is starting from, your range is starting from 0 is included all the way to 30, 30 is included. You can't go beyond these values. It's either you are going to get a 0 or 30 or in between. Those are the values of y. So functions, these functions we are doing in real life, you apply it. When you talk about the range, what is the range? I'm going to get in between. For example, SAP, I'm aiming to get a 90. But even if you get a 90, they are going to put P. They're not going to grade. So that is the range. So even the SAP, there is a range to say when you get a 40, you have to get a what? They are going to put a P. If you get less than this, that is going to be F. Now, when you have got a function like this, like Womba was asking about this, we found that our inverse was, it was 3x minus 5, everything divided by 2x, not so? Then, what we have to understand is that if I get this function, okay, if I have 2 over 0, this will be undefined, not so? So we don't want to have 0 on the denominator. Therefore, we have to get the denominator. We know that this is always defined on top there. So we don't have any issues with the numerator. But our issue is on the denominator. Because on the denominator, once we have 0, then the function is not going to be defined. So for us to make that function to be defined, we have to state the condition to say the down part has to be not equal to 0. Then I need to solve for x. So I'm going to divide both sides by 2, even here by 2, meaning that x is not equal to 0. And for sure, I can plug in any value on x, but I'm not supposed to plug in 0. The moment when I plug in 0, this function will be like 5, negative 5 over 0. This will be undefined. You get it? Hey. You get it? Womba, is that okay? So as long as you have got a fraction, they want you to find the domain, get the denominator, set it not equal to 0. Solve for x. The answer which you are going to find, domain is always x. So you say the domain is going to be equal to x is such that x is not equal to 0, but x has to be the member of all real numbers except 0, but you can plug in all the real numbers except 0. The function is going to be defined. But I've explained. Unless or otherwise. Oh, now here I want us to do, let's take for instance we have a function. You still have questions? Yeah? Yes, it's being recorded. So now I want us, before we go anywhere, even here is there. Before we go anywhere, I want us to even talk about the radicals, where if we have got the function f of x is equal to the square root of 2 minus x, then they ask you to find the domain. Okay, if they ask you to find the domain, we know that we can't have a negative in a square root. Okay, if you have got such kind of thing, just get what is inside 2 minus x, then just set equal to greater than or equal to 0, because we know that we can have only a number 0 going up for this function to be defined. So we're going to solve now x. We are going to say that negative x greater than or equal to 0 minus 2. Then this is going to be negative x greater than or equal to negative 2. Once I divide negative, the sign changes. So it's going to be x less than or equal to 2. Meaning that what it means here, my domain is going to be, this domain is going to be, x is such that x has to be less than or equal to 2, but x can be any real number. So meaning that if I get any value less than 2, this function is going to be defined. What I mean is I can get any value. For example, if I get 2, if I put 2 here, I'm going to get the square root of 0, which is 0. If I get 1, I'm going to get 1. If I get negative 1, it's going to be defined. Does that make sense?
Sir.
Mhm.
Yes, sir. Put a constant in front when you find the range.
I put a constant in front.
Yes.
Which front are you talking about?
Maybe if you say 2 plus
Okay, 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 okay. For example, let's say we have f of x is equal to 2 plus the square root of x plus 3. Don't worry about this. Don't even worry about this. This is already defined, so this will not affect anything. The only thing which is going to be affected is only this part. So you have to deal with the one which is in the square root only. You get my point, eh? Yes. So if I want to find the domain here, I'm going to say that the domain is going to be x plus 3 has to be greater than or equal to 0. Then x greater than equal to what? Greater than equal to negative 3. Meaning that in this function, I'm supposed to put a number greater than what? Greater than or equal to negative 3. Then this function is going to be defined. The moment when I put the number less than negative 3, this function is not going to be defined. You get it? Now, when you want to find the range, just find the inverse of this function. How do you find the inverse of this? That is the simplest, but there's another method which we can use to find the range. But I don't recommend that method because you might be making mistakes. So if I want to find the range, I'm going to say that x, this is going to be 2 plus the square root of x plus 3. Then I'm going to say that this is going to be, I want to make x as a subject of formula. I'm going to shift this to the other side. Y plus 2 is going to be equal to the square root of x plus 3. We square both sides. Even here we square both sides. Okay? So what we are going to have here is, we are going to have y is going to be y squared plus 2y plus, again 2y, not so, plus 4 is going to be equal to x plus, I don't have space this side. And I know this question is, I think is, there's a similar question which is like this. Then I have plus what? We had plus what? Hey, I've forgotten. 3.
3.
Wiz, I think this is the question you asked me about last time.
Yes.
Now what you have to do here is we are going to say that we want to make x as a subject of formula. It's going to be y squared plus 4y plus 4 is going to be equal to, we have x minus what? Or is plus 3. I'm going to shift this to the other side. We are going to have y squared plus 4y. What else do we have? What else do we have?
It could be 4 minus 3, which is 1.
Yes, which is just 1 plus 1, right? Is equal to x. Now, you can see that this function which you have now here, you have this. You don't have any square root. So what will be your range? Come on. What will be the range here? Guys. Okay, let's assume to say you are finding the domain.
If all your numbers.
Yes, all real numbers. So here the range is going to be all real numbers because we don't have the module, we don't have the square root, we don't have the fraction. So if you don't have anything there, the domain is going to be here, like the way we have here. It's going to be all real numbers because those are the values of y. But if you have got, now we I don't want us to spend time. Okay, we have another question there which is talking about the same thing. We have, but I'm going to teach you another method on how to find the range. Maybe that one is going to be easy. But even graphing can give you the range if you are having challenges on how to find the range. Yes.
What if we do that one for limit and multiplication?
Sorry.
What if we use the limit?
If they use the,
If we use the limit and it goes to
I can't get you clear. Wiz, have you gotten the question for Mr. Mbewe?
said if we use limit, like
If we use the what? The limit?
the limit, yes,
Yes, it's okay. It can also give you the same answers.
okay,
Yes, it's okay. You can also use that one. So we have let f of x is equal to, we have this, then g of x is this, so we find fog. So what it means is that in the function of f, where there is x, we need to put g. That's the meaning. So we have we have fog, f of x is going to be, in this function where there's x, we put this. That's the meaning. So where there is this, we are going to put this. Then we say minus 1. So we are going to say that this is going to give us, last time I told you that if I have this, it's the same as 2 over x minus x over x, because x over x is the same as 1, meaning that this is going to give us, the denominators are the same. It's going to be 2 minus x over x, meaning that I have 2 over 2, this, I have this. I don't know if you're confused. Let me know.
Yes, I'm confused.
You are confused, Bron. Okay, what we are trying to say is we find the lowest common denominator here, which is going to be x. X into x1, 1 times 2, we have this. Minus, here we have 1. 1 into x, x times that one, x. So we have this now. You're not confused, right? So we press this with this. That's what I've replaced here. Is that okay?
don't it three, sir?
It's 3. I'm supposed to put 3. Is that okay? It's okay? Hey. Yeah.
So,
Yes. Yes.
so what
Where did you get confused?
The first part for find, is it f of g?
Okay. What's your name, Mama? Naomi.
Once.
Oh, Mansa Kangwa.
Yes.
Kangwa, this is the first time you attending the class. Me, you know, if you don't attend
No.
classes, I know people who attend classes. Okay. So Kangwa, when they ask you to find, this is what we call composite function. They ask you to find fog, which is what they mean is in the function of x, in the function of f, where there is x, put the whole function of g. That's the meaning. You get Kangwa? So what they mean here is where there is a function of x, f, where there is this x, we need to replace the whole of this. You get it?
Yes.
So since we are saying that f of g x is going to be where there is that, we put this. So we want to put that one, what are we going to have? We are saying that this is a function 2 over where there is x, we need to put 3 over x. Then we have also minus 1 there. So we are saying that 3 over x minus 1, it is the same as x. So we are going to have 3 minus x. This. I don't know if you are confused now. You are confused?
No, no.
So this will continue, and this is going to be 2 over where there is the whole of this, we are going to replace with 3 minus x over x. So we know that this now is the same as 2 divided by 3 minus x over x. At the same time, 2 times x over 3 minus x. We have someone who is already confused. We have someone who is already confused.
No, sir.
So meaning here we can now do times where we are going to get where we are going to get where we're going to get what? 2x, eh? Then you have 3 minus x. No one is confused? So f of x, we have 2x over 3 minus x. So this is our answer. Now they want us to find the domain now. Womba, are you still here? Wiza,
Sir.
what are we going to do for us to find the domain?
The domain.
Mm.
We'll equate the denominator to 0.
We equate the denominator to 0. When you say equator, oh, equate, it's more like you are telling me that we do this.
Or not equal to 0, sir.
Not equal to 0. Then we do what?
We take 2 to the other side. We divide by negative 1.
X is not equal to what?
3.
What it means is that I can plug in any value as long as x is not going to be equal to 1. Then That is my what? That is my domain. So this is my domain. The domain is the same as the vertical asymptote, if you don't know. So if they ask you sketch the graph, meaning that this is your vertical asymptote, the graph can't touch this line where x is equal to 3. That will be the vertical asymptote. The horizontal asymptote is the range. You didn't know, ka? Because some of you are having challenges on how to find the domain and the range. Okay.
Sir,
Hmm.
I have a question.
Yes.
If the radical is in the denominator,
Hmm.
what inequality sign do we use? Is it greater than or equal to or just greater than 0?
When the what?
When the radical is in the denominator,
Give me
do we say
gi-
do
give
we say it's
give me the
different in the domain?
give me the example of that question. We use
Maybe
yes, yes.
okay.
Come
Maybe
again.
let's say we have 2 over
Hmm.
root of 3 minus x, right? So do we say it's the when finding the domain, do we say 3 minus x greater than or equal to 0, or just 3 minus x is greater than 0?
Okay. The question here is if you have such kind of function 2 over the root of x plus 3, do we say is has to be equal to 0 or greater than equal to or greater than or equal to 0? What can you say? What can you say? Think. Anyone who can say something? Wiza,
No, sir.
Mbewe.
Sir,
Hmm.
I'm good. I'm good, sir.
So how do we find the domain there?
We equate the down part to 0.
You equate the what? The down part to 0.
Yes.
Why are you saying we equate the down part to 0?
Because most of the time that's what we do so to get the domain.
Okay. Okay, so what you have to do is okay, it's bit what you have to do is you are going to do two things there for you to find the domain. Does that make sense? But do you think such question can come?
No.
Okay, have you seen okay, it can't come as in for the supplementary exams which you are going to write, it can't come, but it's a long method. What you have to do, when I say long, as if I'm talking, okay, what you have to do is you have to get this one, you say it has to be greater than or equal to 0. After reaching at this stage, greater than or equal to 0, then you have again to get this one, you have to set it not equal to 0. You get, then you solve for x again. So I don't want you to be confused, because once you are confused, this one can't come, I know. So I don't know if you want us to continue.
If it can't come, then it's okay.
Okay, in case it comes, so what you do is you have to solve both. You have to make you are going to solve this at the same time you are going to equate this one. You get that guy, then you say not equal to 0. Find the value of x and also y. Then what you are going to do is since this one you are going to get you can even use a number line. So where they are going to intersect, that will be the domain. But it can't come. You even ask me. We can just waste time. So we have found our answer to be this. Now we want to find the domain. So how do we find the domain? Oh, we have found the domain already, right? Where we said x is not equal to 3, negative 3 or 3? 3. So you say the domain is going to be, I don't know how to write this. X is such that x has to be not equal to 3, but x has to be the member of all real numbers. Does that make sense?
So I've got a question.
Yes.
What if we're told to use intervals? Do we
In
like have to plug
no,
numbers from the left?
no, they can't tell you to use the intervals.
Okay.
But finding domain is either you can use intervals or set builder notation. You just choose. So unless you tell me that, sir, what if we want to use intervals?
Yes, sir.
So that one, since we are saying that x is not supposed to be equal to 3, not so. So you are going to say that the domain is going to be, it can be any number. You say that it can be any number from negative infinity all the way to 3, 3 not included, union, also 3 all the way to positive infinity. But 3 is not included, that's why I'm using open.
Okay, sir.
So meaning that this is not included, that's the reason why I'm using open. But in a case where you are using greater than or equal to, for example, let's say that you find that x is greater than or equal to 3, then it's supposed to be domain. So this one, since we are saying that greater than or equal to 3, the domain is going to start from 3 all the way to positive infinity. That is the domain. I'm tired, guys. Okay, so we have the next question, which is saying solve the equation. We have our logarithm, but logs are simple, eh? Don't you think that logs are simple?
No.
Okay, so we have this equation. So where we have, mm, ah, okay, logarithm, as long as you have got the same bases and then there is plus, what we do is we we multiply the what, the function, these ones. So here what we are going to do is we are going to say that I don't know if it's necessary for me to explain the rules of logarithm.
It is necessary, sir.
Yeah. It is necessary.
Yes.
Okay, so if okay, it is necessary. If I have log a, I have log a base x plus log b base x. The bases are the same. What I have to do, this is the same as log a times b base x. If I have log base x, then I have a minus log base x, I have b. This is the same as log x which is base, then A divided by B. The one carrying negative is the one which is going to be on the denominator. So these are the laws of logarithm which you have to know. Now, there is also what we call converting from logarithm to exponential. If I have log A, log x, then I have A is equal to y. This is the same as x raised to the power what is outside is equal to what is inside. Meaning that if I want to put it in exponential, it's going to be x raised to the power y is equal to A. If I have log base 2 of 4 is equal to x, this is going to be equal to what? 2 raised to the power x is equal to 4. The base raised to the power what is outside is equal to what is inside. Log 4 x is equal to 2. This is the same as what? Tell me. Wizard.
2
Mhm,
or 4 to the power 4 to the power 2
mhm.
is equal to x.
So this is how you convert from logarithm to exponential. Now, how do you convert from exponential to logarithm? It is the same. So let's say we have 2 to the power x is equal to 4. Convert this one to logarithm. What you have to know is that always this is the base. Then this is what is going to be inside, and this is going to be what is going to be equal to. This is going to be log base 2. Okay? This is going to be what? 4 is going to be equal to x. Meaning that is 2 to the power x is equal to 4. You get it? Huh? So now we have that formula which we have here. We have this equation which is log 16x then plus the bases are the same. So what do we do if the bases are the same? We are going to multiply this. So it's going to be log 16 is going to be, we have x, open brackets, 10x plus 3 has to be equal to half. What it means here is that this raised to the power half is equal to this. Meaning that it is 16 raised to the power half is equal to x, open brackets, 10x plus 3. I don't know if there's someone who is confused. Do you have people who are confused? Hmm?
No, sir.
So here we know that if we have the square root of, this is the same as the square root of 16, not so? It's the same as the square root of 16. What is the square root of 16?
4.
So here is going to be times x times 10x is going to give us 10x squared plus 3x. So now this is quadratic equation. I'm going to shift this to the other side. I'm going to remain with 0 is equal to 10x squared plus 3x minus 4. Two numbers which when we do plus or minus, we get 3 times we get a negative 40 because we have 10 here.
5 and 8.
5 and 8. So 5 and 8 is 5. Which one is going to have a negative?
5.
5. So it's going to be 0 is equal to 10x squared plus 5x plus minus 8 minus 4. 0 is going to be equal to 5x open brackets. We're going to have what? We're going to have x, 2x, not so. This is supposed to have x, then plus x, then this is going to give us negative 1 open brackets, not negative 1 but negative 2. Okay, I know maybe you are tell me if you are confused before we continue. Up to this point.
It's a 5 to have the negative sign.
Yes, I want to rewrite it. Okay, let's rewrite it. We have 10x squared plus 3x minus 4 is equal to 0. So what I want us to do is, I want us to take, we are saying that we are going to have negative 8 and positive 5. So it's going to be 10x squared plus 5x minus 8x minus 4 is equal to 0. You are saying which one? Oh, this is supposed to be positive, this is negative, right? Vice versa.
Yes.
Negative 5 and positive 8. So meaning here I'm supposed to put, minus 5x plus 8x. So I can factor out 5x. I'm going to remember 2x minus 1 plus, I'm going to have what? I can factor out 2. I factor out 2. 4, eh? I factor out 4. So I'm going to have 2x minus 1 is equal to 0. So these and this, they are the same. I'll get 1. So we have this 5x plus 4, 2x minus 1 is equal to 0. So now I solve for x. Then we are going to have 5x plus 4 is equal to 0. 5x is equal to negative 4. X is equal to negative 4 over 5. We leave it there. Then we come now to this. We come now to 2x minus 1 is equal to 0. 2x is equal to 1. 2x is going to be equal to half. We are not done. I want you first to tell me if you are not confused, then we continue. We are not done with this question. We continue.
Yes.
What you have to do, logarithm, you can't have a log, then you have a negative here. It is undefined. So you check your answers. You have this. So if I plug in negative, this answer here, don't you think that this is going to be undefined? So you plug in, if you get a negative, you plug in. So for example, this is just x. If I put there, I'm going to get log 16, then I'll have negative 4 over 5. So this is undefined. So this is not the answer. The only solution for this equation is x is equal to 1 over 2. That's all. This is the only answer. So you have to show. You tell them. Say the only solution, you plug in there, you start testing. The only solution for this equation is x is equal to 1 over 2. This is not the solution. You even put it there. It's not the solution. Does that make sense? Unless you have questions. Does that make sense?